A quick tutorial to show you how to use the KLD package for measuring the divergence between a reference paleomagnetic pole and a measured paleomagnetic pole. So you'll have found your way already to the website. We simply click the KLD package link. There's code and an example Jupyter notebook on GitHub if you're interested in those kind of things, but the easiest way to run the package is simply via Binder, which you can launch using this button. We just click on that and that'll launch a Binder instance that's linking directly into the package on GitHub. It may take a little bit of time to start up, but ultimately what we'll see is a Jupyter notebook started in your web browser that's fully functional and will do the calculation for you. So the Binder instance has now been launched. The package that we want, or the file that we want, is the kld.ipynb. That's the Python notebook. We launch that. And again, this is running on the Binder server in the cloud. This isn't running locally on your computer. We've got some information at the beginning here, background information, what the various parameters are, and so on. But the key thing to start the software, or to start the package, is to just go to this cell at the bottom, click on it so that it's highlighted in green, and press Shift and Enter together, and that will launch the interface for making the calculation. So within this interface you can define the latitude, longitude, kappa and r that define your different poles. Importantly, your reference pole, so for example a pole from an apparent polar wander path, should be set as pole P, and the pole that you want to compare to the reference pole should be set as pole Q. These two are not interchangeable. You'll actually get different results because the divergence parameter is asymmetrical. So it's important that whatever you are comparing to is set as your reference pole, and your new pole of interest that you want to compare, for example, to a apparent polar wander path, is set as pole Q. You can simply type the information in for your pole, so I'll just update K in this case, hit enter to update the value, and what you'll see is that the KLD value automatically updates and refreshes on the screen. So you can just change these values as you wish, hit enter each time, and what you'll see is that the KLD keeps updating as appropriate. If the two poles are identical, then you'll get a divergence equal to 0, and as the dissimilarity between the poles increases, then the KLD gets larger and larger.